Right, right on top here, please, ladies and gentlemen.
It's a band-aid. What's that called?
Probability.
Oh, that's kind of nasty.
Yeah, you think?
This is for the umpteenth billionth time we've done probability. The only thing I can tell you is this. I think you're pretty good at the whole probability thing here. But the book gives you kind of a little caveat, something a little special and a little exceptional. They give you two different things. They have things that are called independent. I believe it's all E's. Independent events and dependent events. Okay. And the deal with independent, and this is the probability of like multiple things happening. For example, but let me do one. This isn't. Let's do this under independent. Let's say you flip a coin. Here's my coin. I'm flipping. It's either heads or tails, right? Put a little head there. And you spin a spinner, and the spinner is broken into 1, 2, 3, and 4. Okay. And I asked you for, like I said, I'm going to go pretty quick because we've done this since we were forever. If I asked you for the probability of flipping a head and spinning a 4. Okay. Those are called independent events because flipping this first coin has nothing to do with the spinner thing. Okay, whether I flip heads or tails doesn't change the probability of me spinning anything. So it's called independent. It doesn't depend on, the one doesn't depend on the other. How do I find that probability, ladies and gentlemen? Do you remember? To find the probability of these, you take the probability of spinning a head and you multiply it by the probability of spinning a 4, flipping a head and spinning a 4. You could do the whole factor tree thing if you want, do the whole thing and get your sample space and do it, but that's just going to cost you a lot of time and effort there. And it would look like this. What is the probability of flipping a head? It's 1/2, right? There's one head out of two sides. Probability of spinning a 4 is 1/4 because there's only 1/4 out of the 4 things. The probability that you'll do both of those is 1/8. Okay. Now, somebody says, so how is that different than dependent events?
So how is that different than dependent?
Well, as you can probably figure out, the probability of the second event is somehow changed by the first event. And I can really only give you, I would say when you're looking for the book, when it talks about dependent events, look for the words with or without replacing. Because this is what they're going to give you as a thing that's called dependent events. Let's say you've got the proverbial bag filled with marbles. What are our marbles in the bag? Let's say there are, let's go with red ones. Let's say there's 3 reds. Let's say there's 3 yellows. And let's say there's 3 blues. Okay, and I want you to tell me the probability of getting a red marble and then not replacing it and then getting a blue marble. I suppose we should look at both of them, a red and a blue marble. That means this is going to happen. This is why it's called a dependent event. The probabilities are still getting multiplied together. Probability of red, probability of blue. But the issue comes when, ladies and gents, probability of the red marble is what? 3 out of 9, right? 3 reds out of 9 total marbles. The deal is, Jordan Shaw, at this point, if you draw a red marble out, when you find the probability of doing the blue marble, things have changed because no longer are there 9 marbles in there. There's now only 8 marbles because I took one out. And how many of those are blue? Still 3 of them. Okay, so that is why it's called a dependent event, because the second probability depends on what happens with the first one. Now, if they tell you to put the marble back, then it doesn't really change because it'd be the same. But if they pull the marble out, it would also be, well, so what's my answer here, by the way? What is this? This is 1, 3, 1, 1. It's 1, 8, right? Just say yes.
Yes.
Yes. Probably where you would see this a little bit more is if I asked you what would be the probability of drawing the Jack of Hearts and then the Ace of Diamonds out of a deck of cards. And then again it would be without replacing. Hopefully you know something about cards. What's the probability of getting a Jack of Hearts?
152.
Yeah, there's one Jack of Hearts out of 52 cards. Okay, but if I take that Jack of Hearts out, no longer will I have 52 cards for the next draw. I will only have 51 cards. And there's still only one Ace of Diamonds. So the probability of you doing that, ladies and gentlemen, is mighty small. 51 times 52, anybody?
It's
Like 1,000 something.
Wait, are you just guessing?
2,500 something.
Are you just guessing?
Kind of. Yeah, I got it right there.
2652.
Jacob.
By the way, if I were playing a money game with you, like a casino with you, I would offer you, if you could actually do this, I would give you $2,000 if you could pull out the Jack of Hearts and the Ace of Diamonds, and I would still come out ahead because it should only happen 1 out of 2,652 times.
Alright, who has the deck
We should try it, but you'd have to pay me $1 if you don't get it.
of cards?
Okay.
I'll take that risk.
I'll do it.
Colton, would you really? Because I'll tell you, you would lose. See, there's the thrill of gambling. Do you know what the odds of you even? Do you know what the odds of you even picking a Jack of Hearts is on the first time?
Mitchell, if I do it, will you give me $2,000?
Huh?
If I do it, will you give me $2,000?
If you play 2,500 times, Frankie. So you're all just go with it. Gambling is just it's not necessarily a sin, but the thought of it is kind of simple.
That's why you should
Did you get a haircut?
just invest, guys. Invest.
Are you sure? Pull it out in front. I want to see if it goes up here. Oh, yeah. Frankie, your question, I'm sorry.
For the marble game, why is it only 1/8 and not 1/24?
Because I canceled out.
Yeah, but then,
I canceled this 3 out of this 3.
then what is that 3? The 3 to the left get canceled with?
This fraction I reduced to 1/3.
Oh,
And then
okay.
this 3 crossed off with that 3. Sorry, I went a little fast for you there, but. Kel,
What is that?
what is
Under
what?
the
The who?
key.
Without replacing?
Okay.
Have you ever seen that little
What is that?
slash mark? When you put W-O, that sort of without?
Tried it.
I didn't.
I know. Let's look and see if we can't find something, just so you know what the deal is. Oh, and then take out a blank piece of paper, because you need to know this. We always have trouble with this. In case you're ever asked, what is the difference between probability and odds? Who thinks that they know? Conrad, you gave the look like you might have a glimmer of some sort of thought process going on there. Does anybody remember from the past days? Usually when you go to the track and bet, again, I've never done it, they give you the odds of the horse winning, not the probability of the horse winning.
Yeah. I thought 1 in 27 was good.
No.
I mean, if you,
Wait, well, you get a big payout if you win.
I didn't understand it.
You get a big payout if you win. Odds are this, ladies and gentlemen, it's a lot like probability, except it is the comparison. Let me find it, just make sure I write it down right. It is the comparison, or the likeliness, it's written favorable events to unfavorable. Favorable to unfavorable. And I'll tell you exactly what that means. Okay, and and the thing with odds when they bet with horses is you can't, that is, horse betting or horse odds has to be, you can't prove that mathematically, so it has to be, what do we call that, experimental probability, where they look at something. It's not, you can't do that theoretically, because you can't put numbers mathematically to figure out what a horse has got. But let's look at the proverbial spinner again. Let's say I've got 1, 2, 3, and 4. If I asked you the odds of spinning a 4, that would look like this. And we always use this little colon because it stands for the word 2. Favorable would be how many 4s there are. There's only 1 4. And unfavorable is how many there are not 4, which is 1, 2, 3. Okay. Odds would be 1 to 3 as far as odd goes. Probability of a 4 is 1/4. Favorable to unfavorable, favorable to total would kind of be the difference in that. So when Frankie's odds were 1 to 27, okay, that would mean 1 out of 27. One time he'd win, 27 times he would lose. Not there's 28/7 races or whatever. And the payout would be this, Frankie. One, and the reason they do that is because that's the payout. You give them $1, you win, you're going to get 27. You can't really do it here. You give them $1, you win 1, because one of those times is whatever there. So this is the odds. Favorable to unfavorable. Frankie, when did you go?
Yeah.
Frankie, how did you bet?
Yeah, how'd you bet on horses? Are you one?
Somebody bet for you?
I was at the Arlington place for my grandpa's 90th birthday.
Arlington, which could be the home of the new Bears here.
Oh yeah.
Hopefully it'll change their record.
No, it is.
Is Nagy still the coach?
It's already sold.
They did beat the Lions, and that's a
Really
That's a good
accomplishment.
Oh, by a game-winning field goal.
Look at page 208, please. 208. 208, please. Let's just look at some of these here.
They won by a game-winning field.
Is that top of the rep? Is that top of the rep?
Like set it up.
At least you didn't tie.
Oh, it's good.
Look at the practice. I'm just going to ask you, see if you can pick this out. Is this independent or dependent? For letter A, if you choose a card from a deck of cards, replace it, and then choose a second one, is that independent or dependent? Independent, because you put the card back. That's the only reason it's independent. It doesn't change whatever. Letter B, a marble is drawn from a bag kept, and then a second marble is drawn. That is dependent, because it's going to the first one's going to change the odds. The second one. C, a coin is flipped and a number cube is rolled. Independent or dependent? Independent, because you're flipping the number. D, a spinner is spun. The result is recorded. The spinner is spun a second time. Independent, because that first one didn't change anything. Whoa, what does letter E mean? Do we need to do the rest of them? No. What is the probability of choosing pottery and horseback riding on the first day? Are you kidding me? All right, for tomorrow, what time is it? I have a quiz, which people, bulletin board people, you do not need to take. And the rest of you is lesson 33, 1 through 16. I saw a probability. 1 through 16.